All right, happy Wednesday, everyone. It's Ms. Dee, but you can't see me. Hey, it rhymes and I didn't even know it. All right, so we are working on Bellwork 7, I believe. Bellwork 7. And I want you to try and do this on your own. They want you to list the extrema and also talk about the end behavior. So before we even begin, I am going to put arrows on the ends of these. Again, these programs don't always do that, but we should put those on. So I'm telling you now, we should put them on. Okay? So go ahead and pause this and try to do this Bellwork number 7 on your own, and then we'll come back, or you should come back after you've done it and check it. Okay, so hopefully you turn this off, and as I am looking at this first graph, okay, extrema. So there are 4 different types of extrema. We could have an absolute maximum. I could have an absolute minimum. I could have a relative maximum. And I could have a relative minimum. All right, so just because we could have that doesn't mean that it's necessarily going to happen for each item, okay? So as I look at this, absolute maximum. The absolute means it's the highest, and maximum, well, absolute means it's the est. It could be the lowest or the highest, but since it's absolute maximum, I'm talking about the highest point. And as I look here, I don't have any highest points because those arrows tell me we keep going up. So there's none here. And you didn't necessarily have to write these all out, but I'm just showing you these are your options, okay? I see an absolute minimum. So the absolute means it's the est. It's the lowest since it's the minimum. And the lowest point of this graph is right there. And so we write that as -1, 0. Then I'm looking for a relative maximum. That's going to be my hill. All right, and then I look at this graph, I do not see any hills, any areas that kind of go from a decreasing position to, or an increasing position to a decreasing. I don't see any little hills in there, so I'm going to say none. And as I'm looking for a relative minimum right here, that would be what looks like a valley. And as I'm looking at my graph, there kind of is a valley, but we've already named that as our absolute minimum. So there are no other valleys, so that's going to be another none. Okay? All right. So, only thing we have here is an absolute minimum. All right, end behavior. So I am circling the ends of my line. So as x is approaching negative infinity, so as I go towards this way, I see my graph is going up. So that means f of x, the function on x, my y value, or my graph, however you want to put it, is going to positive infinity. It's going up. And as I look at the other one, as x is going to positive infinity, so as x increases going in this direction, My y values are also going up. They are both positive infinity. Both positive infinity. All right, so I hope you did well on that one. Let's take a look at the problem next door. If you haven't had a chance to do it, we can turn this off now, or you should stop the video now. Go ahead and try it. So this is your time to stop the video. And now hopefully you are back. Okay, so extrema. So again, I know I have an absolute max. And I don't necessarily have these, but these are my options. An absolute max, an absolute minimum. I have a relative max and a relative minimum. Those are my options. Okay, so absolute max means, do I have a highest point? Highest point. Well, as soon as I put these arrows on the end, that says my graph really goes up off the page. It continues to go up forever. So I do not have a absolute maximum point here. And likewise, with the arrows going down, I do not have an absolute minimum. So there is no lowest point there. A relative max, that is going to be a slight hill. And I do see that right here. Of course, it's not on the lines. So that would look to be, I'm going to say negative 0.75. So negative, I need to make that just a little bit smaller. So negative 0.75. This is an ordered pair, and it's pretty close enough. It goes a little bit above 2, but we're going to say that's a 2. So negative 0.75 and 2. That's my hill area right there. My relative minimum is the valley. And yes, I see a little valley right here. And so I'm going to say that is positive 0.75. It's not all the way over to what I would call 1 and negative 2. My end behavior. So as x is approaching negative infinity, as I go here, it goes down. So it is also going to negative infinity. And the last one, as x approaches positive infinity, so the more I go positive, yes, it goes down for a while, but then it goes back up. So it is going to positive infinity. So there we have it, the extrema and end behavior for the two graphs below. Okay. All right, so now let's jump into our notes. We have been looking at graphs and figuring out what the extrema are, and similar types of things. Now, here on section 8.4, we are going to sketch the graphs based on the extrema and other things, characteristics that we have been given. Okay? So, let me read over a few things here. Sketching graphs and comparing functions. Mostly sketching graphs. It says, and read along, it says you can use key features of a function to sketch its graph. And these are the key concepts. So the domain, as it says, is the values of x for which f of x are defined. The range are the values that f of x takes as x varies. So those are your y values. Intercepts are where the graph crosses the x or y axis. Symmetry, where one side of the graph is a reflection or rotation of the other side. We've not talked about that a lot, and to be honest, I don't think we are going to need to. And behavior, what the graph is doing at the right and left sides as x approaches infinity or negative infinity. Extrema are the high and low points where the graph changes from increasing to decreasing or vice versa. Increasing/decreasing is where the graph is going up or down as x increases. And then positive or negative, where the graph is above or below the x-axis. Okay, so this says to sketch a linear function. So I have a coordinate plane over to the right, and I am going to sketch this graph based on the features that I am given over here. Okay? So first of all, it says I have a y-intercept at 0, -70. Y-intercept at 0, -70. So that's going to be that point right there. That means my graph is crossing that y-axis at this y-intercept. I'm going to put a little check mark there. Linearity, it says it's linear. Well, what does that mean if it's linear? That means it is going to be a straight line. Okay? So a straight line. Positive. It's positive for values of x such that it's positive when x is less than -30. So when x is less than -30. All right, so when x is here, when it's less than -30, it's going to be positive. So I'm thinking it's going to be like going right here or something like that. That's what I'm thinking. It's decreasing for all values of x. Okay? Positive for values of x such that x is less than -30. So if it's less than -30, like I said, it's going to be positive. Decreasing for all values of x. Okay, so I'm thinking, here's what I'm thinking. Something like this is what we're looking at. And let's check the end behavior. Excuse me. As x is approaching positive infinity, so as x gets bigger this way, my graph is going to negative infinity. Yes, that looks like it's happened. And as x is approaching negative infinity, so as we go further and further negative, my graph is going positive. So hey, that looks pretty good. So it needs to be a straight line. I don't happen to have a ruler. And I think most of you would get the 0, -70. You get that it's a straight line because it says it's linear. It's positive for values of x. So x is going to be positive where x is less than -30. Okay? So positive for values of x, meaning it's going to be above 0 here. So everything above up here, this would be positive. Everything down below would be negative. So it's positive, it goes positive where x is less than -30. Okay, so right at that point. So if I had a nice ruler, I don't have anything here. Maybe I can use a sheet of paper. So if I connect those two, That did not draw. Maybe because my paper is touching. There's got to be some way to lock in here. Yeah, it doesn't like that. So, trying to draw a straight line. Right there, that line in green, that is my function. It's linear. It crosses the y-axis. And at x, where x goes less than negative 30, that's where it becomes positive for any values less than negative 30. Okay, let's take a look at example 2. Now this one, it says it is non-linear. That means it is not going to be a straight line. Not going to be a straight line. So let's keep that in mind. Okay? So some of these things are more important than others. Anytime you have intercepts, those are very important because they usually give you a particular point. Okay? Extrema, that's really important. Says a minimum at 0.3. Now, it doesn't say absolute minimum. It doesn't say relative minimum. So we might have to check into that. And then your end behavior is also important. Okay? So first of all, let's go back to the y-intercept. Y-intercept is 0.3. That's going to be right there. So our graph is going to cross at that point. Okay, we did that. We know it is non-linear, not a straight line. It's continuous. That means it's going to be a solid mark, not a line, but a solid mark, not a dashed line. And it says positive for all values of x. So all the values of x are going to be positive. And it says it's decreasing for all values of x where x is less than 0. Decreasing for all values of x where x is less than 0. So it's going to be decreasing. It says there is a minimum at 0.3. Well, that's my y-intercept. That is a minimum. So I'm guessing they are talking about an absolute minimum there. So that is the lowest point. If that's the lowest point, I'm guessing it's going to be going up. Now, we don't know how wide. It doesn't give me anything else. So I know it's that. If I draw it like that, it is continuous. There's no break in there. It's positive for all values of x. Okay, so all my x values, this is the positive because it's above x equals 0. This is the line, the x-axis. Sorry, that would be y equals 0. The x-axis is y equals 0, but it's positive. It's above all that. It's decreasing for all values of x where x is less than 0. So here's 0, and it says it's decreasing for all values of x where x is less than 0. Well, this is my side where x is less than 0, and it is decreasing the whole entire time. So this looks to be fitting that bill. Okay. So we already said continuous, positive. We did that. We have a minimum. Let's look at the end behavior. As x approaches infinity, f of x approaches positive infinity. So as x gets bigger, my graph is going up. Yes, that works. And as x goes to negative infinity, yes, f of x goes to positive infinity. So as long as you have a absolute minimum here and you draw something of a parabola that's kind of symmetric on both sides, you should be good. Okay? All right. I'm going to go ahead, I think. Yeah. I'm going to go ahead and go through these examples too. And then after all these examples, you can pick up the homework and start on that. I will probably go over these examples again tomorrow, see if you have any questions. But let's take a look. So, test drive. Hay is test driving a car she's thinking of buying. She decides to accelerate to 60 miles per hour. Accelerate, that means to go faster to 60 miles per hour. And then decelerate to a stop to test its acceleration and brakes. It takes her 15 seconds to reach her maximum speed. 15 seconds, okay? And so 15 seconds was right here. So it's going to take her that much time to reach 60 miles per hour. And here's 60 miles per hour. So I'm guessing that she is going to be accelerating at a pretty steady pace. Okay? I don't think she's going to go really fast and then slow down. I think she's going to put the pedal down and try to accelerate to 60 miles per hour. Okay? It takes her 15 seconds to reach her maximum speed and 15 additional seconds. Okay, to come to a stop. So it takes 15 seconds here for her to come to a stop. Well, a stop, what is the speed when you come to a stop? Yes, it is 0. Okay, so it's going to take her that long, 15 more seconds, that should have stopped right here, to come to a stop. So I'm thinking that's what our graph looks like. So let's take a look. Y-intercept. So this is kind of like what we call quadrant 1, where you have positives, okay? So this is as if I had a coordinate plane, and this is what we call quadrant 1. So Hay starts her test drive at a speed of 0 miles per hour. Okay, I have that. Linear or nonlinear? The function that models the situation is nonlinear. So as I look at this whole function, that is definitely not a straight line. So that is nonlinear. Her maximum speed is 60 miles per hour, which she reaches 15 seconds into her test drive. So at 15 seconds, she reaches that maximum amount. So that's good. Hay blanks the speed at a uniform rate for the first 15 seconds. So Hay increases the speed at a uniform rate. I'm going to say increases here. So her speed, as you look and follow this, it is increasing. Okay. And decreasing. Hay decreases the speed at a blank rate. Well, it looks pretty uniform there for the next 15 seconds until she reaches a stop. decreases the speed at a uniform rate for the next until she reaches a stop. End behavior. Because Hay starts at 0 miles per hour and ends at 0 miles per hour, there is blank end behavior. I'm going to say, I should have looked at my notes. Wait, let me look. I want to say that's a no end behavior, because end behavior usually is going to positive infinity or negative infinity. Okay, and it's not a linear function, so it's not staying on the same amount. So the end behavior, there is none. Okay. All right, last one, the check. So this is kind of for you to try on your own. So you can pause this now and try to do the check on your own. Welcome back. Let's see how you did. Okay, so it is non-linear, not going to be a line. Okay, I see some important things here. Y-intercept, that's really important. X-intercept, very important. And minimums. Okay, so y-intercept at 0, -3. There's -1, -2, -3. That's my y-intercept. X-intercept at -1, 0 and 3, 0. 1, 2, 3, 0. Okay. A minimum at 1, -4. Minimum at 1, -4. 1, 2, 3, 4. See, we're already seeing a lot of things here. So, where x is greater than 1, it is increasing. Okay? X is greater than 1, it is increasing. Well, that's definitely increasing. That's going up. And end behavior. As x approaches positive infinity, the f of x is going to positive infinity. Okay, so we keep going there. And as x approaches negative infinity, as I am going towards the negative direction here, my graph should also do that. So here is my graph. Should be pretty symmetric. And that is a parabola. Okay. All right. So there it is. Now it's not quite perfect, but it looks pretty symmetric. Don't mind the spaghetti squash in the oven. So now I want you to pick up, if you haven't already, homework number 3 on sketching graphs. Okay? Try it. We will go over these notes tomorrow and see if you have any questions about this. This homework is going to be due on Friday. So I will see you back tomorrow. I hope you are well. I hope you were well behaved and that you have a great rest of your day. Thanks, and I'll see you